Okay, to begin Unit 6, polynomial functions, we're going to start with quadratic functions. We've already studied some of quadratic functions, and this is going to focus on the graphs of quadratic functions and also application problems with quadratic functions. So a parabola is the graph of a quadratic function, and it's got a smooth curve. It's a polynomial, so it's smooth curved. It does not have a sharp point like an absolute value function would. And there's two different forms that we study. The more useful form is this one that's in vertex form. This book calls it standard form. I tend to refer to it as vertex form, where f of x equals a, parentheses x minus h squared plus k. This comes right after learning about transformations, and that's why I like this form, is I can tell what this graph looks like using transformations. The axis of symmetry is a line. It's got the formula x equals h. And when I'm asking for the axis of symmetry, if you tell me a number, I will not give you credit for that. I need to make sure that you understand it is a vertical line that cuts the parabola in half. Likewise, the vertex is this point hk. H is the x value and k is the y value, and it's for the relative maximum or minimum, and it's always located along the axis of symmetry. The other key points that we look at with this are x-intercepts. We also refer to them as zeros, roots, and solutions. And the y-intercept, which doesn't have any special name, we find when x equals 0. So I'm just going to go through this example and go through every part of this. So the axis of symmetry is the first thing I'll find. So the axis of symmetry is x equals 3. It's very easy to find. You just look back at the equation. Wherever h was here, it's there. So just be careful. This is minus 3 and this is minus h. If this was a positive number, this would be a negative. So x equals 3 is a vertical line, goes through 3. Then we're going to find the vertex. So the vertex is the point 3, 4. This is a positive 4, so this stays positive. If this were minus, then this would be a negative. So 3, 4, so I go over 3, up 4, and I make that point. That is my vertex. Then I also know this negative in front is going to reflect this across the x-axis. So this negative tells me that this is going to open down. So to figure out where it goes to, I'm going to first find x-intercepts. So my x-intercepts, if I have, tell you up here, y equals 0. So I'm going to put 0 equals negative x minus 3 squared plus 4. One of the things we did in the second unit when we were talking about quadratics is solving quadratic equations. So I'm going to solve this using the square root method. I want to get this square term on one side and the 4 on the other. So I'm going to add this to the other side, and it's going to make it positive x minus 3 squared equals 4. Then I can take the square root of both sides, and I get x minus 3 equals plus or minus the square root of 4, which is 2. Add 3 to the other side, I get x equals 3 plus or minus 2. So 3 plus 2 is 5, 3 minus 2 is 1. So my points are going to be 5, 1, or 5, 0, I'm sorry, not 5, 1, 5, 0, right here, and 1, 0. So these can be called x-intercepts, they could be called roots, they could be all zeros. In this equation I was solving, so that's why they would be called solutions. The y-intercept occurs when x equals 0. So I had y equals negative 0 minus 3 squared plus 4. I'm going to just do order of operations. 0 minus 3 is negative 3. Negative 3 squared is a positive 9. So then I have negative, this positive 9 plus 4, which is equal to negative 5. So the point I've got there going to be 0, -5. And what's nice about this axis of symmetry is everything's exactly the same on the left side as it is on the right. So this vertex, then I've got these x-intercepts. This is 2 away from the axis. This is 2 away from the axis. This y-intercept right now is 3 away. So I can go 3 away to the other side. And it's not a y-intercept, it's just another point. And when I graph it, it looks like that. I prefer this one because, like I said before, the parent function is going to be y equals x squared. This negative x minus 3 squared plus 4. This negative in front gives an x-axis reflection. This minus 3 means it's right 3. This positive 4 means it's up 4. All of these 3 things here gives me the transformation. The other form, which is what you're probably more familiar with, is what I refer to as standard form. I think this book calls it general form. It doesn't matter to me that you know the names of the forms, just if I refer to them, I want you to be able to know what I'm talking about. So this is the one you've seen before, ax squared plus bx plus c. So the axis of symmetry is an equation still, but it's negative b over 2a. So there's a little bit more work here. The vertex takes this x value, negative b over 2a, and you plug it back in for x in f of x. And I'll do an example. So here, f of x, wherever x is, I'm going to put this number I got back in there. The x-intercepts are still the same when y equals 0, and the y-intercept is when x equals 0. So if I start here, let's do the axis of symmetry first. So I get x is equal to negative b over 2 times a. So 8 over 4, I get x equals 2. So there's my vertical line. Then I'm going to look at my vertex. I'm going to take this number here, this 2, and plug it back up here for x. So f of 2 is going to equal 2 times 2 squared minus 8 multiplied by 2 plus 3. So f of 2 becomes 2 squared is 4, 4 times 2 is 8. 8 minus 16 is negative 8. Negative 8 plus 3 is equal to negative 5. So my vertex is this point 2, negative 5. Then I'm going to look for x-intercepts. Remember, the x-intercepts occur where y equals 0. So I have 0 equals 2x squared minus 8x plus 3. When I made up this problem, I just randomly chose numbers, and when I was looking at this, I thought, okay, does it factor? And it didn't factor. I could do complete in the square. Quadratic formula is what I'm going to use because I know most of you are familiar with that, and it's going to make you more comfortable. So when I use quadratic formula, I have x is equal to negative b plus or minus b squared minus 4 times a times c all over 2 times a. So x is equal to 8 plus or minus, see, this is going to be 64 minus 24. So square root of 40 over 4. This is going to reduce to 8 plus or minus 2 square root of 10 over 4. So x is going to equal 4 plus or minus the square root of 10 over 2, which is really not a very useful number if you want to graph it. That's what we would have done in the unit when we did quadratics, but let's go ahead and find the decimal approximation because we want to plot these. So the first thing I'm going to do, 4 plus the square root of 10 divided by 2 gives me 3.58. So I know 3.58 is about right there. Then I'm going to come back up instead of a plus sign, I want to make a minus sign. And I get 0.418. A little bit less than half. Which makes sense. I'm a little bit more than 1 to the left and a little bit more than 1 to the right. So you could do this either way. You could do 4 plus or minus the square root of 10 over 2, 0. You can use the decimals. I'll put this answer there. Then we're going to look at the y-intercept. The y-intercept is when x equals 0. So f of x, it's actually f of 0, equals 2 times 0 squared minus 8 multiplied by 0 plus 3. So f of 0 equals 3. So I'm going to have the point 0, 3. It's right here. That doesn't make sense. No. 0. Not paying attention to what I'm doing. 0, 3. This is symmetrical, so it's 2 away from the axis. I'm going to go 2 away this way. So now when I graph it, it looks like this. We are also going to do application problems in this section. I know you don't like application problems, but they really are useful. And it will better prepare you for whatever you do in math later on. Area is a good example of application problem. So if you have an area of a rectangle, say this was x plus 2 and this was x plus 4, you multiply these together, so area would be x plus 4 multiplied by x plus 2, and you're going to have a quadratic. It could be where you have a falling object. So usually, because of gravity, you have an object, if it gets shot up in the air, it's going to come back down in a parabolic shape. So you would have, we're going to have to talk about falling objects, projectiles. And then any kind of products of a linear term. So if you had a product of numbers, say one number was represented by x minus 3 and the other number was represented by x plus 5. And you multiply these together, you're going to have a quadratic.